Tonight, imagine this. You don't move at all. But the universe gains one extra direction, a direction you've never had. What would change first? Light, gravity, or you? Now let's slow down and make it real. When physicists talk about dimensions, they are not talking about secret worlds. They're talking about how reality is measured and how many independent numbers it takes to locate, describe, and predict what happens. So before we ask about interdimensional travel, we need one calm foundation. What is a dimension, really? Start with a point on a line. On a line, you need one number to describe where a point is, left or right. How far? That is one dimension. Now lay the line onto a sheet of paper. Suddenly you need two numbers, left to right and up and down, 2 dimensions. Now lift the sheet into a room. You need 3 numbers, left to right, up and down, forward and back, 3 dimensions. That is the space you grew up inside and the space your body expects. So when someone says, what if there's a 4th or a 5th or a 10th dimension? Your mind tries to picture it like another direction, like a hidden hallway. But here's the quiet truth. A dimension is not only a direction. A dimension is independence. If you need a new independent number, a new independent axis to fully describe something, you have added a dimension. And you already do that every day without noticing. Think about weather, temperature, humidity, wind speed, air pressure, cloud cover. That is not one number. It's a set of numbers. In mathematics, that set behaves like a multi-dimensional space, not a space you walk through, but a space you navigate with information. So your brain is not completely foreign to many dimensions. It's just unfamiliar with many spatial dimensions. That distinction matters because it keeps us grounded. Interdimensional travel, if it ever means anything in science, will not begin with a doorway. It will begin with measurement, with geometry, with how the universe allows paths to exist. So here is the clean question for tonight. If extra spatial dimensions exist, could anything ever move through them in a way that changes what we observe? Not like a person stepping into a portal, but like a particle, a field, a force, taking a route we cannot normally access. To answer that honestly, we need to separate 3 ideas people often mix together. 1. Extra dimensions, if they exist, might be extremely small, curled up, compact, hidden. 2. We might be confined to a slice of reality, even if extra dimensions are larger. 3. Even without extra dimensions, space-time itself can bend and create shortcuts that feel like elsewhere. These are different, and they lead to different kinds of travel. Tonight we'll walk through all 3. Slowly, simply, and with a warm rule. No hype, no certainty where there is none, no fear. Just the most interesting version of what physics can actually say. Before we go deeper, let's make one thing gently clear. Movies teach us a visual language. Bright doors, loud sounds, instant motion. Science often teaches a different language. Quiet effects, patient measurements, small deviations that matter. So if interdimensional travel ever becomes real, it may not look like cinema. It may look like a graph, a clock, a detector, a tiny difference that refuses to go away. And that difference would be the first real clue. Now let's talk about why extra dimensions appear in physics at all. Why would serious scientists ever discuss them? Sometimes the answer is simple. Because the mathematics keeps pulling them back into the room. Certain theoretical frameworks, when written down, become more consistent, or more symmetric, or more stable, if additional dimensions exist. Not because anyone wants a fantasy, but because the equations behave better. This is most famously associated with ideas like string theory, where the math often wants more dimensions than the three we experience. Now, you don't need to accept any particular theory tonight. That is not the goal. The goal is to understand why the idea appears. Physics is like this. When an idea keeps returning from different angles, it becomes worth investigating. Not because it is true, but because it is coherent and because it might be testable. Now, extra dimensions can sound distant, like something far away. But here is something quietly surprising. If extra dimensions exist, they are not necessarily far. They might be right here, woven into the same space you already occupy, just not accessible in the way your senses expect. And that leads to a key concept: scale. Many of the strangest ideas in physics are not about distance, they are about scale. A thing can be right here and still unreachable because it lives at a scale where your body cannot go. So let's enter Scenario 1. Scenario 1. Extra dimensions exist, but they are extremely small. This is one of the most common possibilities in theoretical models because it solves a problem. It explains how extra dimensions could exist without ruining the everyday world. Because if extra dimensions were large and obvious, the laws of physics at human scale might look different, and we would probably have noticed. So the tiny dimension idea is like a quiet compromise. The universe gets extra structure, but keeps daily life stable. Here's a gentle picture. Imagine that long cable again. From far away, it looks like a one-dimensional line, just length. But when you get close, you see thickness, and you realize there is a direction around the cable. If you were small enough, you could travel in that direction, circling around. But if you are large, that direction is irrelevant to you. It exists, but it doesn't function as a travel route. Now translate that to the universe. If an extra spatial dimension is curled up, compact, like a tiny loop at every point in space, then at human size, you would not notice. Your world would still feel three-dimensional because the extra direction is rolled up too tightly. So in this scenario, what would interdimensional travel mean? It would not mean walking through a door. It would mean manipulating reality at such a small scale that you could make that curled-up direction matter. And that is not a normal kind of travel. It is closer to engineering at the deepest possible level. Let's pause and make this feel intuitive. Think about how we interact with the world. You can walk across a room because the room is large compared to you. You can swim through water because the molecules allow motion at your scale. But you cannot step into the microscopic twist of a hair because you were not built for that scale, even though the twist is right in front of you. So the challenge of tiny extra dimensions is not, where is the entrance? It is, the entrance is too small to be an entrance for a body. So could anything travel through it? Possibly, but not a person. If extra dimensions are tiny, then the first travelers would be very simple things: particles, fields, energy. And even then, we would not see them travel like a ship. We would detect their travel as an effect, a missing amount of energy, a slightly altered pattern, a subtle deviation. Now here's a warm idea. If interdimensional travel is real, it might begin the same way many discoveries begin, with a measurement that doesn't match our expectation, and then repetition. Because in science, the first true doorway is not a portal. The first true doorway is repeatability. So what would scientists look for in Scenario 1? They would look for changes in how forces behave at extremely short distances. Because if extra dimensions exist, they may change the geometry of space at small scales. And geometry affects forces, especially gravity. Because gravity in modern physics is geometry. Mass and energy curve space-time, and objects move along that curvature. So if space has extra structure, gravity might be the first force to reveal it. But here is the quiet complication. Gravity is extremely weak and extremely difficult to probe at tiny distances. So even if extra dimensions exist, their fingerprints might be subtle. It might take years and very delicate experiments to see anything at all. And that's part of why this topic remains open. Not because it is mystical, but because it is technically hard. Now let's add another layer. Even if extra dimensions are tiny, they might still influence the early universe. Because the early universe was dense, hot, energetic. At those energies, the small-scale structure of space might matter more. So cosmology becomes a place where extra dimensions could leave traces. In patterns, in distributions, in the way large structures formed. Again, not proof, but a pathway. So scenario 1, tiny dimensions. Travel is not a journey. Travel is a microscopic interaction, revealed through subtle evidence. That's the first picture. Now scenario 2. Scenario 2 is more dramatic in imagination, but it can still be described calmly. Scenario 2. Extra dimensions exist, and they might not be only microscopic, but we are confined. This is where ideas like brain world scenarios appear. They imagine our observable universe as a kind of surface, a layer, embedded in a higher dimensional space. Now, don't picture a physical wall. Picture a rule that says certain things can move in certain directions and certain things cannot. Just like a train can move along tracks, but not off them. The world is not blocked by a wall. The world is guided by constraints. If we are confined to a brain, then most familiar matter would be bound to it. Light, electrons, protons, atoms, they would live and move within our three-dimensional space. But in some versions of these models, gravity might behave differently. And here we reach a key curiosity: why gravity is so weak. Hold a paperclip and bring a small magnet near it. That tiny magnet can lift the paperclip against the gravitational pull of the entire Earth. That means electromagnetism is strong, gravity is weak. So why is gravity weak? One speculative explanation says, maybe gravity is not truly weak. Maybe gravity spreads into extra dimensions, while other forces remain confined. Like sound spilling into neighboring rooms. If the gravitational field spreads out into additional dimensions, then what we feel in our slice might appear weaker. Again, not proven, but interesting, because it connects to a real puzzle. Now, what would travel mean here? If matter is confined, the human body cannot simply step out. So interdimensional travel would mean finding a way to couple matter to whatever can access the higher dimensional space. And we don't know how. But science can still ask, what would the evidence look like? If gravity leaks, then at very short distances, gravity might deviate from the usual inverse square law. Or in high-energy particle collisions, some energy might appear to vanish because it moves into extra dimensions. These are the kinds of signatures scientists discuss. Not a portal, a missing piece. Let's make this feel calm and clear. Imagine you live in a world made of a thin sheet, and you can only move left and right. You have no concept of up and down. Now imagine something exists above your sheet, and it touches your world without being fully inside it. It would appear to you as a strange influence, a force, a pattern. You might not see the full cause, but you could notice the effect. This is how we might relate to extra dimensions, not by seeing them directly, but by seeing the way they shape what we can measure. Now there is another gentle idea here. If our universe is confined, then interdimensional travel might not mean leaving. It might mean interacting. It might mean that certain kinds of waves or certain kinds of gravitational phenomena could move in the higher dimensional space, and we might be able to detect them, like hearing sound from the next room. Again, small hints, not dramatic scenes. Now, Scenario 3. Scenario 3 is often confused with extra dimensions because it also creates the feeling of elsewhere. Scenario 3, even without extra dimensions, space-time itself can bend. This is established physics. Mass and energy curve space-time, and curved space-time changes the paths things can take. So in principle, shortcuts can exist, not by leaving our dimensions, but by changing geometry within them. This is where wormholes enter the conversation. In popular culture, wormholes are doors. In physics, wormholes are solutions to equations, possible geometries that connect distant regions. Imagine 2 points on a sheet of paper, far apart. If you fold the paper, those points become close. Now, it's only a metaphor, but it captures the essence. A shortcut is not about moving faster, it's about the shape of the path. But here is the sober part. Wormholes, if they exist, may be unstable. They may require conditions we do not know how to create, or energy distributions we do not know how to sustain. So once again, possible in math, unknown in reality. Far beyond engineering, at least today. Now let's tie together the 3 scenarios. Tiny extra dimensions, confinement on a surface, curved space-time shortcuts. All of them can be called interdimensional travel, depending on what you mean by the word. But the human imagination wants a specific thing, a human experience. So let's bring the question back to human scale. If interdimensional travel ever becomes real, how would it begin? The calm answer: it would begin as a measurement, a small effect, a repeatable deviation, not a traveler, a trace. Now, let's deepen this with a few simple, memorable pictures. Because this topic becomes easier when your mind has images to hold. Here is one picture. A 2-dimensional creature lives on a flat plane. It understands left and right, forward and backward, but not up and down. Now imagine you, as a 3-dimensional being, push your finger through the plane. To the flat creature, your finger is not a finger. It is a circle that appears, grows, and shrinks, and disappears. The creature would be seeing a cross-section, a slice. It would never see the full cause. Now hold that thought. If there are higher dimensions, we may be like the flat creature. We may see slices, shadows, cross-sections, not because we are foolish, but because our senses evolved for a limited window. So the job of physics is to infer the larger structure from the slices we can measure. Now we can ask something gently. If we are seeing slices, what would a higher dimensional object look like to us? You might have heard of a tesseract, a 4-dimensional hypercube. It's a concept that appears in mathematics and sometimes in explanations of higher dimensions. In simple terms, it is a 4-dimensional analog of a cube. But how do you see a 4-dimensional object when you live in 3 dimensions? You can't see it directly. You see a projection. Just like a 3-dimensional object casts a 2-dimensional shadow, a 4-dimensional object would cast a 3-dimensional shadow. So what you would observe is not the full object, but a changing shape, a transformation that seems strange, a shape that appears to twist through itself, not because it breaks rules, but because you are seeing a projection. This is a calm way to understand a key idea. Higher dimensions might not look like new places. They might look like weird patterns in the place we already know. Now, let's make interdimensional travel sound less like a fantasy and more like a realistic scientific question. Instead of asking, can a person travel to another dimension? Ask, can information travel in a way that requires an extra dimension to explain? Can energy take a path that appears impossible in 3 dimensions alone? Can gravity behave as if it is spreading into more directions than we can see? These are scientific forms of the same curiosity. Now we can ask, what would we notice first if an extra dimension existed and mattered? Earlier we asked, light, gravity, or you? Let's explore that. Light is a good candidate because light is sensitive to geometry. But light also travels in very predictable ways, and we have measured it carefully. If extra dimensions influence light strongly at human scale, we might have noticed. So if extra dimensions exist, the effect on light is likely subtle or confined to extreme conditions. Gravity is a good candidate because gravity is geometry itself, and gravity remains mysterious at small scales. So gravity is often the first suspect in serious discussions of extra dimensions. And you, your body, your perception, you are the least sensitive instrument. Your senses are adapted to survival, not to measuring subtle geometric deviations. So interdimensional travel, if it begins, will not be felt in your skin first. It will be seen in instruments. This is not disappointing. It's actually reassuring, because it means the universe is stable and our lives are not constantly on the edge of invisible chaos. If extra dimensions exist, they exist quietly. Now let's do a gentle thought experiment. No portals, no explosions, no danger. Just a calm scenario. Imagine that the universe has one extra spatial dimension, but it is normally hidden. And imagine there is a device, not a doorway, a device that slightly changes conditions so that the extra dimension becomes a little less hidden. What happens? First, most likely, nothing that your eyes would notice. Because if the universe has an extra dimension and daily life is stable, then the extra dimension is either very small or very weakly coupled to ordinary matter. So your room remains your room. But in sensitive instruments, you might see a shift. For example, an object might weigh a tiny fraction more or less, not because its mass changed, but because gravity's geometry shifted slightly. Or a clock might tick differently, not because time changed globally, but because the structure of space-time affects how clocks measure intervals. Or a particle detector might see a pattern that suggests energy is moving into an unseen route. That's how the first hints would likely appear. Now, let's address a question that many people feel. If extra dimensions exist, where are they? Are they somewhere else? Or are they here? The calm answer: if they exist, they are likely here. Not as a hidden room, but as a hidden direction, folded into the same location. So the universe would not be waiting behind a wall, it would be woven into the place you already are. This is why the topic feels so strange, because it asks you to imagine that reality has more directions than you can point to. Now, one more careful distinction. Many people mix extra dimensions with parallel universes. They are not the same idea. Extra dimensions are about geometry, how space might be structured. Parallel universes are often discussed in the context of quantum interpretations, how outcomes might be described. Both are fascinating, but they are different questions. Tonight, we stay with geometry, because geometry is already enough. Now, to make the second half of this episode richer, let's explore what travel could mean in a few more grounded ways. Because travel is a word that hides multiple meanings. Travel can mean a physical object moving. Travel can mean a signal moving. Travel can mean a force spreading. Travel can mean a path existing. So interdimensional travel could be any of these, and each would imply a different kind of evidence. For example, if gravity can leak into extra dimensions, then gravitational waves might behave differently than expected. Gravitational waves are ripples in space-time, and they carry information about massive events like black hole mergers. We detect them with instruments that measure unbelievably tiny changes. So if extra dimensions exist, there are discussions about whether gravitational waves could reveal them. Not because they travel to another world, but because their propagation might include extra routes. This is the gentle version of travel, a signal that spreads in more ways than we can see. Another example. In particle physics, energy conservation is one of the deepest rules. So if a collision seems to lose energy, scientists don't casually say, "It went to another dimension." They test everything first. But in principle, missing energy is one of the ways extra dimensions might be inferred. Not as a story, as a possibility. Again, travel becomes a path for energy. Now, Let's build a calmer intuition about higher dimensional motion, because the word travel suggests a map. So let's draw a map in your mind. Imagine a city. In a normal city, you have streets, and you can move along them. Now imagine the city is not only streets, but also tunnels beneath and bridges above. If you only know streets, you might think two places are far apart. But if tunnels exist, two places can be closer than you expect. Now, that is not extra dimensions. It's just extra routes. But it shows how travel depends on available paths. Extra dimensions would be like additional kinds of routes, not visible in the street map. So travel becomes a question of, what routes does reality permit? Now, another gentle concept, topology. Topology is the study of properties that remain under continuous deformations, like stretching or bending. It is a kind of geometry, but more about connectedness than distance. Sometimes in physics, the shape of space can have topological features, like handles, loops, connections. In such cases, a journey could exist that is not obvious from local observation. This is one reason wormholes feel plausible in mathematics, because geometry and topology allow surprising connections. Again, this doesn't mean wormholes exist, but it shows how travel can be a geometric property. Now let's talk about what would be required for a human to travel interdimensionally in a way that resembles imagination. The steps would be 1. Evidence. Clear evidence that extra dimensions exist. 2. Interaction. A mechanism that allows matter to couple to those dimensions. 3. Control. A method to guide and stabilize a path. 4. Return. A way to come back. Even one of these steps is difficult, and it's okay to say that, because saying it calmly is not pessimism, it's honesty. And honesty keeps the topic fascinating, rather than confusing. Now, let's slow down again and focus on one warm, central idea. If interdimensional travel ever becomes real, it will not arrive as a surprise to physics. It will arrive as the last step of a long chain. First, theory. Then, subtle evidence. Then, stronger evidence. Then, a reproducible effect. Then, engineering. In other words, interdimensional travel would likely be an endpoint, not a beginning. Now, to keep your mind gently engaged, let's revisit the opening question. If the universe gained one extra direction, what would change first? We said, probably not you, and probably not visible light in daily life. Most likely, gravity, or very small-scale physics. So in a calm way, the first change would be a rule in the background, a quiet shift in how influence is spread. Not a sudden new world. This is important because it means something. It means if extra dimensions exist, they are compatible with stability. They are not chaotic. They are quiet architecture. Now, let's create another thought experiment, even calmer, more personal. Imagine you are lying in bed, and you could sense geometry, not with your eyes, but with a quiet intuition. You sense that space is not only left, right, up, down, forward, back. You sense an additional degree of freedom, one your body cannot move through, but that reality can. In that world, what would travel mean to you? It might mean not going somewhere, but changing how things connect. Your physical location might not change, but relationships between events might. Distances might not be only distances. They might depend on hidden geometry. This is a subtle way to understand something that physics already teaches. Even in our real universe, distance is not absolute. In relativity, what you call distance and time depends on motion and gravity. So the universe already shows us that our intuitive map is not the final map. Extra dimensions would be another extension of that lesson. Now, because this is a sleep-friendly channel, let's bring a gentle calm into the structure. We'll do a quiet recap, then one more deepening section, and then a soft landing. Quiet recap so far. A dimension is an independent axis of description, a number you need to fully specify where something is. We are comfortable with 3 spatial dimensions, and we often include time as an additional coordinate. Extra spatial dimensions are not confirmed, but they appear in some theoretical frameworks. If they exist, they might be tiny and compact, or we might be confined to a slice, or space-time geometry might allow shortcut-like structures. In science, travel begins as a measurable effect, not as a dramatic doorway. Now, one more deepening section. Let's explore a question that quietly matters. Why are humans so captivated by extra dimensions? Because our minds are built to search for hidden structure. When you see a shadow, you intuit there is a form behind it. When you see a pattern, you intuit there is a rule behind it. Extra dimensions feel like the ultimate hidden structure, a rule behind the rules. But physics is careful. It says the only hidden structures worth believing are the ones that leave measurable traces. So the right emotional posture here is curiosity and patience. Now, let's explore what kind of traces would be most meaningful. If extra dimensions exist, they might alter gravity at tiny distances, high-energy particle collisions, cosmological patterns, or the behavior of black holes and early universe physics. These are the frontiers where geometry shows itself most clearly, and this is why you often hear extra dimensions mentioned alongside the smallest scales and the largest scales, because those are the places where our everyday intuition breaks. Now, a gentle, final thought experiment. Imagine that an extra dimension is not a place to go, but a place to store. A kind of geometric storage where information or energy could temporarily spread. Then travel might be information taking a hidden shortcut, and you might never see a portal. You might only see a strangely correlated event, a faster than expected connection, a subtle missing piece that returns later. Now, I'm not claiming this happens. I'm showing you how science can translate a fantasy word into a measurable question, because that translation is the calm heart of this channel. Now let's land. Interdimensional travel, as a human journey, is not something physics can promise. But the question itself is not childish. It is a legitimate curiosity about geometry, structure, and what space might be. And sometimes, the most comforting thing is not an answer. It is realizing that the universe is bigger than your worries and quieter than your fears. Not louder, just larger. So tonight, as you rest, hold one gentle idea. If extra dimensions exist, they are likely not behind a door. They are likely here, folded into the same space you already know, quietly present, and detectable only through careful measurement. And that means, even if we never travel there, the question still does something beautiful. It reminds you that your mind can be curious without being restless, curious and calm. In the next episode, we'll take another impossible-sounding idea and make it quiet. What would happen if time itself paused for just 10 seconds? For now, let the question stay open, not as fear, but as soft curiosity.